Hi there. My name is Patrick Hodap. I'm a postdoctoral researcher in the Brazil group at the KIT. And over the next few minutes, I will be introducing the Chemotion ELN to you. Uh, Before we start, let's quickly take a look at the chemotion.net webpage. This is the official webpage of the Chemotion project. And here you will find more information. I invite you to look and take a look at it after the video. Because you will also find the other projects related to the Chemotion. These include the Chemotion repository, ChemScanner, and SpectraViewer, which I will not be covering during this video. But just to mention quickly what the difference between the Chemotion Lab Notebook and the Chemotion repository are. The Chemotion Lab Notebook is a locally installed web-based ELN. It needs to be installed either by your institute or your university or the company you're working at. While the Chemotion repository is a hosted web page hosted by the KIT, where researchers can upload reaction data and analytics or the single molecules with its data and make this available to other researchers. For each data set you publish, you will get an individual DOI. And you can include this in your manuscripts so other researchers can access the raw data and the analyzed data that you uploaded. Now, on the webpage, you will find the link to the repository. You will find the link to the test server of the ELN, where you can create an account and play around with the ELN. Please do not upload any relevant scientific information, as this is only a demo server for testing purposes. You will also find the chem spectra that you can try out and the chem scanner. There are some videos to introduce the basic functions of the ELN if you're just getting started with using this. And you will also find a link to the ELN source code published on GitHub. Chemotion ELN is an open source project. You can download the source code and install it locally at your university or a server in your institute, and will be then able to access it from a web browser. So the ELN is a browser-based system. I just switched to the screen you will see once you have logged onto the electronic lab notebook. You can use any browser to access it. It's optimized for Chrome and for large screens. But in our labs, we're also using Android tablets in the lab to work with the ELN, so this does work. Let's look at the arrangement, how the ELN is organized, what you're looking at, and then go through the main functions of the ELN. Due to time constraints, I will not have the time to go into each of the functions and in depth, but you should have a good overview of the capabilities the ELN offers. So in the top of the window, you see the administration toolbar. This has the possibility to search. You can move your reactions, delete reactions or samples, export reporting, and the account administration. On the left, you have the organization of your workspace. So you have collections where you can group reactions according to the different projects you're working on. You also have your inbox and the data that was shared with you by other ELN users. We will go into detail on that in a minute. And in the center, you have your active workspace. Right now, we're just looking at a list of reactions from one of my PhD projects. If you open any reaction or a single molecule, your screen will, or your workspace will split screen. On the left, you will still see the summary of the collections you're looking at. And on the right-hand side, you will see the reactions or samples that you opened. You are not limited to how many tabs you can open. You can work on many reactions at the same time. And once you're done, you can just close them individually, save them individually. Now let's work our way from top to bottom and go through the main functions. So if you click on the name you registered with, you will open a drop-down menu where you can change account and profile details, your password, affiliation groups, and you see the link to My Devices, which are the analytical devices that have been integrated into the ELN, should there be any at your university or institute. Let's look at the last two I mentioned. One is the affiliations, where you can set your affiliations depending on what institute and what groups you have been working in. And you have the groups that you can create or can be added to by whoever created a group. This is very interesting when you want to share something with your entire lab, either in chemicals database or projects you have been working on, and whoever administers the group can add and remove team members, thereby always having a current list of everybody working in the lab. And you know that if you shared something with a group, then everybody active in that group will be able to see that. This is also the way that you can share devices, or that devices are integrated into the ELN. Um, the device list is created as a group, and everybody added to that group will have access to this device. However, we will look at the analytical device integration at the very end of this video. On the left, you have the collections. The collections are the projects you are working in and help organize your workspace. This way, you can group your reactions or samples into collections and have an organized workspace. You're not limited to how many collections you can create, and you can create sub-collections of collections, thereby refining the group. You can also assign a sample or a reaction to multiple collections at the same time. Once you go into the collection settings, you will see the list of all your collections, and this is also where you can share it with other people or with groups. Just as an example, I have a list that are my chemicals and reagents I regularly use. And if I want to share this with somebody else, I would just open the share window, pick a role. This role will set all the elements below to a predefined setting. Or I can just go one by one and fine tune what level of detail and I want to use when sharing this with another person. At the end, I need to search for the person I want to share it with, and I will click on Create Sync Shared Collection. The other person will get a pop-up notification informing them that I have shared something with them, and then they can access the collection. What does it look like from the other side? So if somebody synchronized something with me, their synchronized collection will show up in this synchronized with me drop-down menu. And from here, I can open the collection that has been shared with me. And depending on the level of detail it was shared with, if this is a cooperation project that both are working on, it makes sense to share it with a level of detail that I can also add information and edit the reaction details. If I'm just a cooperation partner that somebody just wanted to share the product and some analytical data with me, that is also possible. In that case, I would only see the product and the data that was shared with me and not the entire reaction with the reaction description. So you can really fine tune what level of detail you want to share this with other people with. Let's stay on the left-hand side. You have some more drop-down menus here. The inbox, for example. If you have integrated analytical devices into the electronic lab notebook, they will be able to send the data, the experiment data to you directly. Here you see some devices that I have used that send data to me. All the data sent by devices will land in the inbox, and I have to manually sort it into the correct experiment. We'll see how this works in a minute. Now, let's look at the search function, and then we will go to the active window and look at what creating a reaction is like and what information you can input. So search function allows you to search not only for a molecule via SMILES code, UPAC name, INCHI key. It also allows you to search, for example, for a reaction status, or draw a molecule and search for the molecule by similarity. That is also possible. So basically you can search for many of the things that you insert into reactions. If you're looking for special advanced searches, that is also possible. Here you can really fine-tune the search and search for even more parameters than you can by just using the standard search. Now let's have a look at what creating a reaction actually looks like and what information you can put into. Let's open a reaction. The screen will split in two, as mentioned before, and on the right-hand side you have the reaction you opened. You also have various tabs where you can put information pertaining this reaction to. The first one being scheme. This is basically everything you used to write into your handwritten lab notebook. So you have the reaction scheme, you have the table of reactants grouped into starting materials, reactants, and products. You can add solvents and reaction conditions. In this reaction, I did not use a solvent. However, let's add a solvent, and you will see that it's added below the arrow. You can also add reaction conditions, either by selecting from a predefined list or by manually writing information into the text box below. So you're free to add whatever information was necessary, and this will also show up below the arrow. You can give this reaction a name. Every reaction is given a sequential number. And if you want to give the reaction additional name, or if you want to name reactions with additional information, you can do that here. You can tell, you can say what status the reaction is in, either a planned reaction, it's running, done, analysis is pending, it was successful or failed, what temperature the reaction was done at. You can also add temperature gradients. If, for example, you started the temperature at the reaction at minus 20 degrees, then heated it to 0 degrees for 2 hours, and then to reflux conditions for a few hours. You can add all that information. You also have timestamps. These timestamps make it fairly easy to tell the system when you started and stopped the reaction. However, they're not to control the users, but more as a help, so you can modify them manually and input the information manually. You also have the reaction ontologies. So these are really long lists. However, you can search for something. And once you have selected something, they will show up next time in the recently selected to make it easier to find it. You also have the reaction role. You can add reaction as a general procedure, parts of a general procedure, or single reaction, We will see in the reporting tool, which I will cover in a minute, why this is important. Once you created a general procedure, you can then assign single individual reactions to this general procedure. You have reaction description. In the reaction description, you are free to write the text as you want. And just as an additional help, you have text fragments that you can quickly add. You can also select the reactants from the table, and this information will be added automatically to your reaction description, making it very easy and fast to write a reaction description while working in the lab. Then you can select what type of purification you used for this reaction, and describe the precise purification steps taken. In the next tab, we have more properties and more reaction specific description and information we can add. And then we have a reference tab. Here you can just add the DOI number. It will search for the original publication and add this as a hyperlink. So you can click on the hyperlink and will land directly on the publisher's site where you can download the PDF. And you have the analysis tab. In the analysis tab, you will see at least two separate tabs. One is for the entire reaction, and the other one is for the purified, isolated product. You are not limited to the amount of analysis you can add to a reaction or a product, and also not limited to the types of files that you can upload. This can have any type, any format, just like an email attachment. And once you added something, it will look like this. You will get a preview. For the previews, you can either add a PDF, a JPEG, or a PNG image. And for the file types that the system can recognize, it will create the preview automatically. You can give the analysis a name, tell it if this is confirmed or unconfirmed. This is something you do yourself. And you can search through a long list of ontologies, or if you use something recently, choose it from the dropdown. You can add the analyzed text for this analysis, additional description if necessary, and the original dataset. Here you can also give the dataset a name, tell it what instrument it was measured in. Description, should that be necessary, if it was measured at a very specific temperature or with defined parameters, or a specific procedure was used, and you need to record this. And upload the file from your computer, or by dragging and dropping a file sent to you directly from the analytical device. Should the system recognize the file type and be able to read it, as is the case, for example, for JChem files for spectroscopy, so NMR, Raman, IR, UV-Vis, or mass spectrometry, MZXML, or Thermo Fisher .raw format, for example. If a file type has been recognized, then the Spectra Editor button will show up in blue. And this way you can open the spectrum, either mass spectra, NMR spectra, or whatever was recognized. It will show you what layout it was, depending on the file type it recognized. And you have the editing tools to analyze your spectrum. In this case, we're looking at a proton spectrum, so I can peak pick, I can analyze the multiplets, and at the end, I can report everything in the correct format. This will be done automatically It's also available for IR spectra, mass spectra, where the individual peaks will then be reported in the right format by just clicking a few buttons. Next, let's look at the reporting tool. If all the information was added to the ELN in the correct format, you can generate supporting information for your manuscript directly from the ELN. In this case, let's just look at a standard report. You can select the reactions that you want to report and the level of detail that you want the report to include, and set the order of the reactions, how you want them. Label is only available when you're creating a supporting information, because the molecule numbering scheme has to be the same as in the manuscript, of course. In the preview, you can check that everything was included the way you wanted it to be reported. And at the end, you can generate the report. This will usually take 30 seconds to 1 minute. And then you can download the Word document and have a look at it. Just by example, let's download a Word document that I already generated in the past and open this. It's not natively generated in Word, so it just creates two messages. Just accept these and you will see the report with the level of detail that you want it to include. So you see the reaction status, you see its name, what collection it's in, the reaction scheme and the table, description, and I didn't want any more detail included. But you can also add the references, you can add analytical data and all that information. Once the report that we generated is done, you will get a pop-up notification. These pop-up notifications are available, are a way to inform you of status changes. So if somebody shared a collection with you, you will receive a pop-up notification. If a report you generated is ready, you will see there's a pop-up. And if the system admin updated the server, you will also get this as a pop-up notification. It will not interrupt your work, so if the system is updated, you can continue working until the end of the day when all your information and all your reactions and everything is saved. And by refreshing the browser, you will be working with the latest up-to-date version. Now, since we already covered the analytical data in the reactions, and I mentioned that when devices are integrated, you see the analytical data that was, or the experiment data sent to you by the devices in your inbox. Let's look at the device list that I mentioned at the very beginning of the video, because you can not only receive the data from the devices, you can also control these devices remotely. Once you enter the devices list, on the left-hand side, you will see a list of all the devices integrated into the ELN. And let's just open one example, one of the LCMS devices in our lab. And here you see the device can be controlled as if you were sitting right in front of that computer. When you go into the focus mode, you are no longer in the spectator mode and you can control the device. You can set up your experiments and you can start them remotely. And at the end of the experiment, the device will upload the file to the ELN. I will not go into the details of how this is technically done. It would go beyond the scope of this video. However, we have found methods of integrating almost any analytical device in the lab. So we have multiple solutions for the different systems, depending on what operating system they're running on, what the proprietary software limitations are, and so on and so forth. And with that, I want to conclude this video. I hope you got a good impression of what the Chemotion ELN can offer and what you can do with it. And I hope you have the time to check out the chemotion.net webpage to also take a look at the other projects involved, and maybe create a demo account to try out the ELN for yourself.